Imagine this. You're in your living room, sipping your coffee. Suddenly, you decide you want to be in New York City. With a snap of your fingers, you're there, standing in Times Square. No travel time, no airplanes, just instant movement. While this might sound like something straight out of a science fiction movie, the idea of teleportation is rooted in real science and could, one day, change the way we live. What is quantum teleportation? Before we dive into teleportation, let's talk about something called quantum teleportation. Quantum teleportation doesn't mean the physical transfer of objects, like in the movies. Instead, it's the transfer of information at the most basic level on a quantum scale. Let's say you have two particles that are entangled. Imagine they're like twins that always know what the other is doing. If you change the state of one particle, the other one instantly knows about it, no matter how far apart they are. It's like magic, but it's real science. This is quantum entanglement, and it's what makes teleportation possible on a very small scale. In simple terms, quantum teleportation allows information to be teleported from one place to another without actually moving the physical particle. This has been proven in experiments with light particles and atoms. Recent breakthroughs in teleportation. Now, you might be thinking, that sounds cool, but how does this help us teleport stuff, like people? Well, let's talk about the exciting breakthroughs happening today. Long-distance teleportation. Scientists have already teleported information over long distances. In fact, researchers in China sent quantum information through space over 1,400 kilometers using a satellite. That's farther than most of us will ever travel in a lifetime. This proves that it's possible to send information over huge distances without it getting lost. Better quantum computers. One of the biggest challenges with computers today is connecting them in ways that are fast and secure. Quantum teleportation could link quantum computers across the world, making them faster and better at solving really complex problems. Imagine being able to solve huge puzzles in minutes that would normally take years. Noise as a friend. Now, here's something weird. In quantum physics, particles are sensitive to noise, stuff that messes with their state. But in recent studies, scientists have found that adding just the right kind of noise can actually improve teleportation, making the transfer of information more accurate and faster. Is physical teleportation possible? You might be wondering, that sounds cool, but can we teleport ourselves, like in Star Trek? The short answer is, not yet. While we're making huge progress in transferring information, teleporting physical objects, like people, is still a long way off. Here's why. Imagine you're trying to teleport a simple object, like a chair. To do this, we would need to completely break it down, molecules and atoms, and then send that information somewhere else. When the chair gets to the new location, we'd have to rebuild it, atom by atom. This is a massive amount of data and would be incredibly hard to do. Reconstruction. Another challenge is making sure the object is rebuilt exactly the way it was. Even the tiniest mistake in reconstruction could change how the object looks or works. So, while quantum teleportation works for information, it's not yet a solution for physical teleportation. Real-life applications of quantum teleportation. Even though we can't teleport ourselves just yet, quantum teleportation still has some super cool real-world applications. Quantum computing. Right now, computers are pretty powerful, but they still have limitations. Quantum computers can solve some problems much faster than regular computers. By using quantum teleportation, we could link quantum computers over long distances, allowing them to share information and solve problems even faster. Super secure communication. One amazing feature of quantum teleportation is that it could make communication impossible to hack. That's because if anyone tries to snoop on the quantum information being transferred, It would mess up the entire process, making it immediately obvious that someone is tampering with it. Think of it like sending a secret message through a lock that can never be picked. The moment someone tries to break in, they'll trigger an alarm, and the message will self-destruct. This level of security could revolutionize how we send sensitive information. What are the ethical and philosophical questions? Now that we've seen how cool quantum teleportation can be, it's time to think about the big questions. What happens to identity? If we could teleport people, would they still be the same person after being reassembled in a different location? For example, if you were disassembled and then put back together, would your consciousness stay the same? It's a huge philosophical question, and scientists don't have all the answers yet. Security and privacy. Imagine if teleportation became available to everyone. You could be anywhere in an instant. But what if bad actors used teleportation to break into places or steal things? Would teleportation become a tool for crime? There would need to be strict rules to keep everyone safe. Conclusion: the future of teleportation. So, what have we learned? Teleportation, as we know it in movies, isn't quite possible yet. However, the science behind quantum teleportation is real, and it's opening up exciting possibilities in fields like quantum computing and secure communication. While we're not teleporting ourselves or our luggage just yet, scientists are working hard to make it a reality. The future could look very different, and we might one day look back at these early breakthroughs as the beginning of a new era, where distance and time no longer limit how we connect and move across the world. Stay curious about what comes next. The science of today is the magic of tomorrow.